Hi guys, this is a demo of simple event management system created on Java platform for demonstrating secure coding principles. The video will be showing implementation of 5 secure coding standards with their insecure versions. As an application overview, it's a basic desktop application which communicates with MySQL database server using various REST APIs. We have implemented security standards at various levels, few in the application itself, others in the REST APIs and the database.
Now I'll be showing various insecurities, starting with SQL injection. You can see that I've opened both insecure and secure versions of the application. Now along with any random username, I'm entering the injection string as the password. And we can see that I can log in as a legitimate user like this. Now trying the same in the secure version and pasting the same injection. One thing to note here is that now the password is not visible to us anymore, and we get this error message and we are unable to log in. As the security standard, the authentication functionality uses stored procedures, and authentication happens at the server end. No information is stored in the front end and hence cannot be exploited. In the secure version, the remaining database requests use either prepared statements or stored procedures. Next, I'll be talking about some of the input validations in the registration module. This is the insecure version. As you can see, there are no validation checks in this. In the secure version, it checks if all mandatory fields are entered. Now entering pass in the first field and password in the second field, we see that password is validated by the retype password. Furthermore, it verifies the strength. The rules are that it should be at least of 8 characters long. Also, it should contain one capital letter, one special character, and one number. Now entering the password as password at 1234. Other fields can either be null or should follow the appropriate validations. Also, throughout the application, required validations have also been implemented. Now I'll demonstrate cross-site scripting. This is the home page of the application, and this page shows the list of all the events. Here we can see the detailed information of any event by entering its event ID in this field. As we can see, it is generating an HTML page displaying all the details. This can be exploited to do a cross-site scripting attack. Passing this injection string, we are able to demonstrate an attack. Now logging in the secure version of the application and opening the same page. If we pass the same string, we get the following error message. So in the secure version, we are validating all the inputs with the event IDs, and hence any such attacks are difficult. Now I'll demonstrate how we are handling sensitive information in the application. In the insecure version, we can see that while logging in, the password entries are visible. While in the secure version, it is hidden. In the insecure version, we see that all the information is being logged, and hence critical information can be extracted from that. In the secure version, the logs are created such that no crucial information is ever leaked out. The application also logs all the incorrect login attempts, which can help us to identify brute force and DOS attacks. Furthermore, passwords of the users are handled very carefully. They are sent directly to the database server via stored procedures for authentication and erased as soon as the process is completed. Inside the database, all password entries are hashed using SHA algorithm. In addition to this, no other crucial information is kept in the cache, and while logging out, the application deletes all the user information from the session. Lastly, I'll be demonstrating clickjacking. For this, we have implemented a functionality of creating invitation pages for events. First, I'll show how the invitations are generated. We enter two event IDs, and this creates an HTML page showing the invitations. By, by opening this link, the user is redirected to the Facebook page so as to follow the event. By entering a script, an attacker can trick users and redirect them to any fishy page that he wants to. Here you can see that we are inserting an iframe tag having 0 opacity, which is covering major part of the page, and as the user wants to go to the Facebook page, he'll be redirected to the page mentioned in the script. Here it is Board Panda. So here we can see that when we click on the page, he'll be redirected to the Board Panda page instead. To explain the attack, now we'll increase the opacity and rerun the whole script. Now when we open the HTML page, we can see how the script frame is covering the links and the details. Now doing the same thing for the secure version. Again, we are validating all the inputs with the event IDs, and hence any such attacks are difficult. So this completes our demo, and as always, thanks for watching.